Welcome back, students. Today is the Q&A session 7 from the chapter of laws of motion, and today I have taken two questions, one from the topic of equilibrium of concurrent forces, and the other one will be from the topic of law of conservation of momentum. So this question is from the topic of the equilibrium of the concurrent forces, and we have discussed about this topic in the session number 6. So the question is, a mass of 5 kg is suspended by a rope of length 2 meters from the ceiling. A force of 50 Newton is applied at the point P of the rope as shown in this figure. So a force of 50 Newton is applied at this point P of the rope, and this is a horizontal force, means this force is applied in the horizontal direction, and this is the 5 kg mass which is suspended by this rope. The mass of the rope is neglected here, and the value of the g, that is the acceleration due to gravity, will be equal to 10 meter per second square. So we have to find the tension in the rope and the angle the rope and the angle which the rope makes with the vertical. So this is the rope. So since we know that the tension in the rope will be directed away from the point of application of the force, so this tension will be directed in this direction, and suppose this tension is T. ठीक है, ये आपका रोप है, ये आपका रोप है, and so this tension is since it is directed away from the point of application of force, therefore now this tension will have two components. One will be the vertical component, so and one will be the horizontal component. Now this horizontal component will be directed in this direction, ठीक है, and the vertical component जो है वो इसका इस direction में होगा. Let us say this rope, ये जो rope है, it is making an angle theta with this vertical. ठीक है, अगर ये angle theta हो गया तो ये भी angle theta हो जाएगा. Now अगर if the tension T is directed away from this point of application of this force of magnitude 50 Newton, then the vertical component, this component will be equal to T cos theta, मैं यहाँ लिख रहा हूँ, and this horizontal component जो है, this one, I'm just rubbing it now here. So यहाँ पर हो जाएगा आपका T sin theta, ठीक है. So if the tension T is directed in this direction, that is it is directed away from the point of application of the force, so this tension will have two components, that is one, this is the vertical component which is equal to T cos theta, and the other one will be equal to T sin theta, and this T sin theta will be directed in this direction, that is it will be opposite the direction of this horizontal force of magnitude 50 Newton. So in this way, now if this mass is in a state of equilibrium in such a way that the rope is making an angle theta, theta with the vertical, okay, then we can say that T sin theta will be equal to 50 newtons, ठीक है. ये जो आपका this mass है, this will be in a state of equilibrium on the application of this horizontal force of magnitude 50 Newton only when this horizontal force is balanced by the horizontal component of this tension T, and the T cos theta, this is the vertical component of this tension, and it will be balancing the the weight of this mass. So if it happens, that is, if t cos theta balances the weight of this mass, and if t sin theta is equal to the horizontal force of magnitude 50 Newton, and it is acting in the opposite direction, then t sin theta is equal to 50 Newton है, और t cos theta जो है that is also equal to 50 Newton. ठीक है ना, बिकॉज ये 5 kg इसका आपका मास है, और जो g की वैल्यू है वो हमको लेनी है 10 मीटर पर सेकेंड स्क्वायर. सो दी वेट विल बी इक्वल टू 5 into 10, दैट इज इक्वल टू 50 न्यूटन हो जाएगा. नाउ ये इक्वेशन 1 हो गई मेरी, दिस इज द इक्वेशन 2 हो गई. व्हाट आई विल डू इज, नाउ आई विल डिवाइड बोथ दीज इक्वेशंस on the left hand side and on the right hand side of the equations. So ये अगर करने पे हमें क्या मिल जाएगा, tan theta. Tan theta will be equal to 1 और theta will be equal to 45 degree. That is, in a state of equilibrium, when in the state of equilibrium, when a horizontal force of 50 Newton is applied at the point P, then the angle made by this rope with the vertical will be equal to 45 degrees. ठीक है, ये आपका पहला पार्ट हो गया. सेकंड पार्ट है, we have to find the tension in the string. तो tension in the string हम निकाल सकते हैं. Since we have found the value of theta, that is equal to 45 degree, so we can put this value in any one of these equations. So t sin theta is equal to 50 है. Now so t will be equal to 50 divided by sin theta. So which will be equal to 50 divided by sin theta is equal to sin 45. So which is equal to 50. Now sin 45 क्या होता है मेरा? This is equal to 1 by root 2. So tension in the string will be equal to 50 root 2 newtons. ठीक है? So if this mass is in a state of equilibrium on the application of a horizontal force of 50 Newton magnitude at the point P, then the rope will make an angle of 45 degree with the vertical, and the tension in the rope will be equal to 50 root 2 newtons. इसको और सिंप्लीफाई करना चाहते हैं तो we can do it also, that is 50 into 1.414 I think. So this is equal to, or if I just multiply it by 1.4, so it will be equal to approximately it will be equal to 70 newtons. ठीक है, so this was the first question. Now let's move on to the second question. The second question is, a body of mass 1 kg initially at rest a body of mass 1 kg initially at rest breaks into 3 pieces or explodes into 3 pieces in the ratio 1:1:3. The two pieces of equal mass fly off perpendicular to each other with a speed of 30 meters per second. What is the velocity of the heavier piece? So ये question है, and this question was asked in the this IIT examination long time back. So इसमें ये लिखा हुआ है कि there is a body of mass 1 kg and it explodes into 3 pieces in the ratio of 1:1:3. So इसका मतलब ये हो गया कि let us say if there are now after this body explodes into 3 pieces, so we can say that the mass of one body, that is which I have this denoted here as m1, is to mass of the another body which I have denoted here by m2, and m3 is the mass of the heavier piece, ठीक है, which I have denoted by m3. So m1 and m2 are are having the equal mass, and this is the heavier piece. So अगर इनका ratio है, if they are exploding into 3 pieces in the ratio of 1:1:3, then m1 is to m2 is to m3 will be equal to 1:1:3. और हम ये कह सकते हैं, it implies that m1 का जो मास होगा that will be equal to 1/5 kg, और this will be equal to the mass of m2 also, and ये कितना हो जाएगा, this will be equal to 0.2 kg. और m3 का जो मास है, that is this is the m3 is the mass of the heavier piece, so this will be equal to 3/5 kg. So this is equal to 0.6 kg. ठीक है, तो हमारे पास में ये 3 आ गया. So I will just write it here now. m1 का जो हो गया है मास हो गया है, that is equal to 0.2 kg, and this is also equal to the mass of the second piece which I have depicted as m2, and the mass of the third piece which is the heavier piece, इसका मास हो जाएगा मेरा 0.6 kg. ठीक है, which we have just calculated from here. Now हम यहाँ पे डायग्राम बनाते हैं. ये है आपका this is the mass, this is the body of mass 1 kg. Now it explodes into 3 pieces, but mass m1 और जो m2 है, जिनका they fly off perpendicular to each other, मतलब इनका जो बीच का एंगल हो गया वो 90 डिग्री है, with a velocity of 30 मीटर पर सेकेंड. इसका भी जो वेलोसिटी है वो 30 मीटर पर सेकेंड. ठीक है, तो अब यहाँ पे हम एक, now this is the horizontal. Since the velocity of these two masses are equal, and since their mass is also equal, so we can say that the angle made by this velocity vector will be equal to 45 degree, and this angle will be also equal to 45 degree. So we can say that इसका जो मास अगर है हमारा m1 है और इसका मास है हमारा ये m2 है और दोनों का मास जो है वो 0.2 kg है, तो मोमेंटम इन द हॉरिजॉन्टल डायरेक्शन क्या हो जाएगा, दैट विल बी इक्वल टू m1 into the horizontal component of this velocity, which is equal to what, it will be equal to 30 cos 45. So 0.2 into 30 cos 45, और क्योंकि इसका भी जो हॉरिजॉन्टल कंपोनेंट है वेलोसिटी का वो भी आपको 30 cos 45 ही होगा और मास भी सेम है, तो ये हमारा हो जाएगा इंटू 2. ठीक है, तो ये हो जाएगा मेरा 0.2 हो गया 0.4 इंटू 30. Now cos 45 is 1 by root 2. ठीक है, so this is equal to 12 divided by root 2. ठीक है, yeah. So now we can write it down here, that is the horizontal component of momentum of m1 and m2 is equal to ठीक है, ये आपको हो जाएगा, विच इज हम इसको ऐसे भी लिख सकते हैं, विच वी कैन बी रिटन एज 12 रूट 2 बाई 2 एंड सो दिस इज इक्वल टू 6 रूट 2. अच्छा, वर्टिकल कंपोनेंट क्या होगा आपका, इसका जो वर्टिकल कंपोनेंट है वेलोसिटी का ये आपका आएगा ऐसे करके, तो इसका जो वर्टिकल कंपोनेंट है दैट इज द ऑफ दिस मास m1, it will be directed upward, that is this velocity component will be in the vertical direction will be equal to 30 sin 45. और m2 मास का जो वर्टिकल कंपोनेंट है उसका भी मैग्नीट्यूड तो सेम ही रहेगा, बट इट विल बी डायरेक्टेड डाउनवर्ड्स. सो द मोमेंटम ड्यू टू दिस vertical component of the velocity of the mass m1 and m2 will cancel out each other because इनका जो डायरेक्शन है they are opposite to each other. तो हमें ये कंसिडर हमें करना ही नहीं है. तो हमें जो कंसिडर करना है वो करना है खाली दिस हॉरिजॉन्टल कंपोनेंट ऑफ द मोमेंटम ऑफ दिस मास m1 एंड m2. ठीक है, सो ये हो गया हमारा. नाउ ये एज पर द लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम, दिस हॉरिजॉन्टल कंपोनेंट of this of the mass the horizontal component of the momentum of this mass m1 and m2 will be equal to the momentum of this mass m3. ठीक है, and this mass will move or it will fly off in this direction, that is it will be in the opposite direction of the horizontal component of the velocity of this mass m1 and m2. तो ये इस डायरेक्शन में जाएगा. सो ये हम लिख सकते हैं इसको, इसका जो है मोमेंटम कितना हो जाएगा m3 और इसका लेट से इसकी जो वेलोसिटी है आई एम जस्ट टेकिंग इट एज v3. सो दिस इज द मोमेंटम ऑफ दिस मास एंड दिस विल बी इक्वल टू 6 रूट 2. ठीक है, नाउ सो v3 कितना हो जाएगा, v3 विल बी इक्वल टू 6 रूट 2 डिवाइडेड बाई m3 ना m3 का मास कितना है 0.6, so this will be equal to पॉइंट हटा देंगे जो 60 है, that will be equal to 10√2, ठीक है ना। v3 का जो so the velocity of this mass, this is m3, or you can say the velocity of the this heavier mass will be equal to 10√2, or you can say meter per second, ठीक है। और इसको अगर हम और सिंप्लीफाई करना चाहते हैं तो इसका आंसर हो जाएगा, आई विल जस्ट राइट इट डाउन हियर, मैं इसको यहाँ लिख लेता हूँ ऊपर v3 को, दैट v3 विल बी इक्वल टू, अगर √2 है, √2 इज इक्वल टू 1.414 होता है, सो ये हो जाएगा 10, v3 इक्वल टू 10√2 विच इज इक्वल टू 10 इंटू 1.414, or we can write it down as 14.14 meter per second, ठीक है। या सो दिस इज दी यहाँ पे हमें जो क्वेश्चन पूछा गया था कि वी हैव टू फाइंड द वेलोसिटी ऑफ द heavier piece, so the velocity of the heavier piece will be equal to 14.14 meter per second, and here we have used the principle of, or you can say the law of conservation of momentum. Here the momentum in the vertical direction is not taken into account, because the direction of the vertical component of the velocity of this mass m1 and m2 are acting in the opposite direction, and since their value is equal, since see क्योंकि इन दोनों का जो जिस वेलोसिटी है वो 30 मीटर पर सेकेंड था, तो इनका जो वर्टिकल कंपोनेंट है वही बराबर है, बट सिंस दे आर एक्टिंग इन द अपोजिट डायरेक्शन, सो एज अ रिजल्ट ऑफ दैट द वर्टिकल कंपोनेंट जो है दिस द मोमेंटम ड्यू टू द वर्टिकल कंपोनेंट ऑफ देयर वेलोसिटी आर गेटिंग कैंसल्ड आउट। खाली हॉरिजॉन्टल कंपोनेंट है, दिस m1 का जो हॉरिजॉन्टल कंपोनेंट है इट इज एक्टिंग इन दिस डायरेक्शन, and the horizontal component of this velocity of this m2 is also acting in this direction, so momentum दोनों का एक ही डायरेक्शन में हो गया, the moment that is the horizontal component of the momentum, ठीक है, that is in this direction, m1 का भी इस डायरेक्शन में है और m2 का भी इसी डायरेक्शन में है, ठीक है। इसीलिए तो हॉरिजॉन्टल कंपोनेंट जो है आपका दी हॉरिजॉन्टल कंपोनेंट ऑफ द मोमेंटम ऑफ मास m1 एंड m2 जो हमने निकाल लिया, और इसके बाद में सिंस दिस एज पर द लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम, दिस मोमेंटम विल बी इक्वल टू द मोमेंटम ऑफ द दिस हेवियर पीस, जिसको हमने डिपिक्ट किया है यहाँ पे बाई m3। तो इसका अगर m3 का मास हमारा 0.6 है, उसका मैंने वेलोसिटी कंसिडर किया, आई हैव टेकन इट एज v3, सो m3 इंटू v3 विल बी इक्वल टू 6√2, फिर इसको मैंने यहाँ से m3 का आपको मास पता है दैट इज इक्वल टू 0.6 है, सो हमने यहाँ पे वी हैव फाइंड द वेलोसिटी ऑफ द हेवियर पीस विच इज इक्वल टू 10√2 मीटर पर सेकेंड, एंड और इसको सिंप्लीफाई किया तो वी हैव गॉट द वेलोसिटी एज 14.14 meter per second. So this is all I have for this session, and in the next session I will be taking up the topic of motion of connected bodies, and thereafter we will be again in the session number, I think in the session number 9 I will be again continuing with the QA this question and answer sessions, and so till then thank you very much for joining, and have a nice day. Bye.